Assalamualaikum and good day everyone. So I would like to actually do one example, one beam example analysis of beam, indeterminate beam using moment distribution method. Okay, so let's start. I just want to draw the beam using ruler here. So let's say this is the beam. Okay, so it is a continuous beam, so I put fix, roller, fix, and we label as A, B, C, and D. So this is fix, roller, fix. Okay, so for the loading, so I put here is UDL and point load. So point load at the center and point load not at the center. Point load at the center and point load not at the center. So the value is 250 kilonewton. This is 50 kilonewton per meter, and this is 100 kilonewton. Okay, so we are going to analyze this. Calculate member and moment using MDM, means moment distribution method. Moment distribution method. Okay, the distance. Okay. Okay, so the distance, this is 2 meter, 2 meter, 3 meter, this is 3 meter, and 1 meter. Okay, so we are going to analyze this. Assume EI is constant. Okay, assume EI is constant. Okay, so we are going to analyze this. So for the procedure, number one, we have to calculate K and DF. K and DF. K is member stiffness. Member stiffness, and then total K, and then we have to calculate distribution factor. Distribution factor is K divided by total K, or member stiffness divided by joint stiffness. Okay. Number two, we have to calculate fixed end moment. We have to calculate fixed end moment. Fixed end moment means we have to analyze member that is subjected, that we have to analyze loading that is subjected on member, along member. Okay, fixed end moment means that we have to distribute moment to the joint. We have to distribute moment to the joint, and fixed end moment is behavior. Okay, this is FEM, the second step, and FEM is actually the first member and moment in the table. First member and moment in distribution table. First member and moment in distribution table. Okay, so once we have determined distribution factor, and then we calculate FEM. So the next step is we have to draw a table, and we have to start distribute moment. Start distribute moment. in distribution table. Distribution table. And under the table, in the table, we will have two steps. Number one, or A, we have to distribute moment. We have to distribute moment. Distribute moment. Distribute moment, or to be specific, distribute join moment. Distribute join moment. Distribute join moment. And number two, or B, we have to carry over the value. We have to carry over moment value. Okay, that these are the two process in the table that we have to do it repeatedly. We have to repeat again until the moment the last distribution reaches zero value. Okay, so we start now. Okay, we have AB, the leg is 4 meter, BC, the leg is 3 meter, and CD, the leg is 3 meter. EI constant, and K, the formula for K that will be used here, okay, for AB, for BC, and for CD, we will use K, which is equivalent to 4EI over L. 4EI over L, because all members we can use formula for far and fixed. That is for calculating K. Means that what we get is, this is the solution. Okay, so K, we have K for AB. K for AB, it is 4EI divided by 4, which is equal to EI. And then we have K, we have member BC. Always remember that K is member stiffness. KAB, KBC. So depending on how many member that is given. Okay, KBC is 4EI over 3. So this will be 1.333 EI. And KCD, for member CD, this is 4 EI over 4 again. So this is equal to EI. Okay? And always remember that to distribute distribution factor, the formula is K divided by total K. K divided by total K. So, and how many distribution factor in this diagram? In this question, we have 6 distribution factor because we have member AB, member BC, member CD. This is member AB, member BC, and member CD. So, this is MAB, member and moment, MBA, MBC, MCB, MCD, and MDC. So these are six member and moment, which means that we have to have six distribution. Okay, 6 value of distribution, 6 values, because it must be equal to number of member and moment. Because when we calculate member and moment, we have to times with the factor, time with distribution factor. Okay, so we have the 6 label in the table. We have 6 label AB, BA, BC, CB, CD, DC. Okay, 6 label. Okay, so now we will calculate distribution factor. Distribution factor. This is DF, and we have 6 distribution factor. We will start with distribution factor for AB, and at point A it is fixed support. Fixed support means we have to divide by infinity. It is K divided by total K. K AB divided by K AB plus infinity. So due to this is equal to 0. And same thing goes to DF DC, which is equal to K for member CD. We divide by K CD plus infinity. Okay, so we have now another 4 distribution factor. We have DF ABBA, ABBA. So it is K for member KBA. So it is for member AB, or the easiest way to understand this, just put like this: KBA over KBA plus KBC. B here, B here. And always remember that KAB and KBA is the same. It's KB. KB. So for KBA we use KBA, we use KAB. It is EI. It is EI. Okay, it is EI over, it is EI. Because EI will be cancelled, so we just focus on number. Okay, it is 1 divided by 1 plus 1.333. Okay, because KBA is also KAB and it is equivalent to EI. So we just consider 1 here because EI now is cancelled. And then KBC is 1.333. KBC is 1.333. So KBA is actually 1 per 2.333. It is 1 divided by 2.333. So we get 0.429. So this is equal to 0.429. Okay, do not put any unit, just like this. Okay, DF, now we move to DFBC. DFBC. Remember, we have AB, 6. We have BA, we have BC, we have CD, we have D, ABA, BC, ABBA, BC, CB, BC, CB, CB, CD, DC. CD, DC. So we have get this 2. We have get BA. Okay, now we want to calculate DF for BC. DF for BC. It is actually, we can write like the previous one, KB, now is KBC, right? So it is DFBC means KBC divided by KBA, KBA plus KBC. Okay, BA, BC. This is for KBC. Okay. This is for DFBC. So for BA here, because AB and BA is equals, so we use KAB. So this is equal to KBC is 1.333 divided by 2.333, and this is equal to 1.333 divided by 2.333, we get 0.571. 0.571. 0.571. And in total, if we check back, 0.429 plus 0.571, this equal to 1.0, equivalent to 1, because distribution factor at joint equal to 1. So actually we can also use this 1 minus K B A, we get 0.571. Okay, you can use either one, whether you want to use KBC per KB, or we can use 1 minus KBA to get DFBC. Okay, so we do the same. So now we have already get this one. So we have another two, KCB and KCD. Okay, we have to repeat the same process, and we get KCB, we will get DFCD, and remember, these two equal 1, these two equal 1. This is 0, this is 0 for distribution factor because of fixed support. Okay, so now we move to fixed end moment. Fixed end moment, the concept is it representing behavior. For example, if this beam AB is subjected to point load, or is subjected to maybe UDL, or any type of loading which is subjected on member, along the member, okay, so it will produce deflection. Okay, the beam will bend, and due to the loading at both fixed end, there will be moment that will push back the beam to its original position. So we call this counterback forces as fixed end reaction, and this is fixed end moment. Okay, fixed end moment, to push back this to straight position, of course we have to apply, okay, like what you can see right now. Okay, so that this is fixed end moment. So this is fixed end moment, and always remember that fixed end moment is behavior. Okay, so the formula is always given for the fixed end moment, given in appendix. So you don't have to remember the fixed end moment formula. You just need to know how to use it. Okay, refer back to the question. So member AB, member BC, member CD, all these member have loadings on member. AB is subjected to 250, subjected at the middle of AB, and then member BC is loaded by uniformly distributed load along member BC, and member CD, okay, that is a vertical load that is subjected 1 meter from D. Means that each member A, B, B, C, C, D have fixed end moment. Okay, we calculate it one by one. So for AB, it is subjected at the center. It is 250, 2 meter. Fixed end moment is in this direction. So the formula is WL squared over 12. This is the formula. Sorry. This is the formula for UDL. It is PL over 8. PL over 8. PL over 8. Okay, PL over 8, PL over 8. So now calculate the value. It is 250. L is 4. L is 4 divided by 8. So we get 125. We get 125. So the answer here is 125. 125. 125, 125. So this is member AB. Member AB. So FEM. So FEM AB equal to, because it is counterclockwise. So it is opposite with sign convention. So it is negative 125 kilonewton meter. And FEM for BA equal to positive. Positive, it is clockwise and similar direction with sign convention. So this is also 125. 125. Okay. So move to the second member. The second member is 3 meter length, 50. 3 meter length. Okay, it is 3 meter length. Okay, we must assume all are fixed. Okay, it is 3 meter length, 550 kilonewton per meter. Okay, so the moment act in this direction, the formula is WL squared over 12 for both. Okay, we calculate the value. It is WL squared over 12. WL squared over 12. WL squared over 12, it is 37.5. So this is 37.5, 37.5. So FEM, because this is BC, okay, FEM BC equal to negative 37.5 kilo Newton meter, and FEM CB equal to positive 37.5 kilo Newton meter. Okay, and last one. Okay, last one. Okay, refer to the formula. Refer to the formula of fixed end moment. It is 1 meter. Sorry, 1 meter here for 3 meter. Okay, it is 100. It is 100. 100. So moment act in the same direction to counter back. Okay, so I want you to continue. Okay, find the value. So this is A. This is not A. This is C and D. This is C. This is D. Okay, so find the value. So FEMCD will be negative value, and FEMDC will be positive value. Okay, so then after we have calculated all the fixed end moment and distribution factor, then we can start distribute moment in the table. Then start distribute moment in distribution table. And in distribution table, we have to list all the members. Members means all the uh, member and moment. Okay, previously I have told you that there are 6 member and moment, so we have to have 6 column for that one. So we have column for AB, and then BA, and then BC, CB, and then CD, DC. So we have can be like this, the table. Okay, we have member AB, member BC, and member CD. Okay, one member has 2N, one member has 2N, so that is why we will have 6 in total. We will produce, okay, we will have 6 member and moment. Okay, so the first value that we have to put in the table will be distribution factor. Distribution factor. Okay, so here is 0, here is also 0. We get 0.429 and 0.571. Okay, and I don't calculate this value, so please complete it. But remember, the total must be 1. Total equivalent to 1. Okay, so then after this is the fixed end moment. Okay, we have to put the fixed end moment that we get, okay, from this step. So we have to put negative 125 and positive 125. Negative 125, positive 125, and then we get negative 37.5, negative 37.5, and 37.5, and I leave another 2 value blank, and I want you to calculate this value. Okay, so next after this is the distribution step, distribution moment step, the first step, the first distribution. So we will start with distribution here. Distribution, we start with distribution, and we will distribute moment. And always remember that the moment that we distribute is the joint moment, which is opposite with member and moment. And fixed and moment is the first member and moment in the table. So distribution, and then carry over, and then repeat again distribution, and then repeat again carry over. So carry over, we use the factor for and fixed equivalent to 0.5. Okay, repeat again distribution, repeat again carry over, repeat again and again and again until the last distribution reaches 0 value. Okay, until we get here 0.0 something, here also 0.0 something, maybe negative 0.0 something, then we can stop the process. Okay, once we stop, so we have to sum. Okay, find the total moment. We have to find the total moment. Okay, one by one. Find the total moment. Put here. Find the total moment. Put here. Until we get all. Okay, until we get all. So the process, the distribution process in the table, please refer to the video, the recording video, that the link I have given to you previously. Okay, so that is the moment distribution method. This is analysis of beam. Okay, so you have to understand this. You have to understand all this process. The most important thing is distribution factor. and fixed end moment. Make sure both value are correct. So to calculate distribution factor, we have to calculate stiffness factor first, and please make sure the stiffness factor also correct. Please use the right formula based on the far end condition. Okay. To understand more, please watch more than one recording video. I have a lot actually in my channel discuss about moment distribution method. So I want you to complete this. I want you to complete this, and I will check by tomorrow. Okay, so that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much.